coming to the power flow to a transmission line, our aim is to find the various parameters. Suppose if I am saying that in a power circle diagram, we are going to discuss about the power circle diagram, where there are receiving end circle diagram and sending end circle diagrams are there. So to find the receiving end circle diagram, to find the receiving end parameters, we have to go for receiving end circle diagram. So here, what happened mean, suppose I want to find, if I am sending this much of power, what is the condition to get maximum power at the receiving end, how to increase the maximum power, those things we can able to see. And based on these expressions, there are two equations I said, one is the receiving end power, other one is the reactive receiving end real power, other one is the receiving end reactive power. Using these two expressions only, we are going to solve the circle diagram. So to solve the circle diagram, if you see that, to solve the circle diagram, so this is the circle diagram for the receiving end. First you need to identify how much is the radius of the circle. To identify the radius, you see the expression Vs into Vr by B. That will give you the radius of the circle. And A into Vr square by B, that will give you the coordinate of the circle. A into Vr square by B is the coordinate. And how much angle it is tilted, since both are negative. Both are value A minus R, see this is minus A Vr square by B. If you operate with cos or sine, both are coming negative. That is why the center of the circle is here. Both are negative. Okay, that is the third quadrant. Then from there, at an angle of beta minus alpha from the negative x-axis, draw one line for a magnitude of A Vr square by B. A Vr square by B will give you the magnitude, and at an angle of beta minus alpha, so that will give you the corresponding value. So A Vr square by B, so that will give you the corresponding value over there. So here, this line that you have to identify. Then to find the radius of the circle, radius is Vs into Vr by B. To find the radius of the circle, what you have to do is use this operation Vs into Vr by B. From here, from the center of the circle, draw an arc for the radius Vs into Vr by B. Okay. Then after this is the first step. First step, you need to identify that what is the identify the center of the circle. To identify the center of the circle, so what you have to do is at an angle of beta minus alpha, draw one line whose magnitude is A Vr square B. Let us say A Vr square B, by substituting Vr, it should be a line value. After substituting that, if you are getting the value as A Vr square B as 500 megawatt, for example. If I assume 1 unit is equal to 100 megawatt, then 5 centimeter is the scale. At an angle of beta minus alpha, I have to identify the center of the circle and draw one arc for the radius of Vs into Vr by B. So these are the things we have to do first. And after doing that, so what I have to do is, if suppose theta r is given, if I am going to deliver the load to the receiving end power at an angle of maybe 36.86, how I arrive at the angle in the sense, if the power factor is known, if the cos pi r is given as 0.8 or 0.9, from there you can find what is the value of pi r. Then after finding the pi r value, just at an angle of that, you just draw one line and find the operating point. So that operating point will give you the value of how much is the real power. If you see this, how much is the real power it can able to deliver, and how much is the reactive power you have to support to deliver that much of power. So these are the various cases. And other than that, there are another question that is it possible to find what is the maximum power I can able to deliver using these things. If that is the case, what I will do is, see, from the center of the circle, you just draw one line which is parallel to the, from the center of the circle, draw one parallel line with respect to x-axis that will touch the arc. Then from this point, wherever it is touching the y-axis to the circumference of the circle, you just measure what is the distance. Then convert that into the power scale. If you do that, the corresponding number, the corresponding value which you are getting is the corresponding maximum power you can able to deliver. So this is the receiving end circle diagram. First step is you have to identify the center of the circle. The center of the circle, using this receiving end power expression, you find the value of the second coefficient. There are two terms are there. The second term will give you the coordinates. So A Vr square by B, both are negative. That is why it's the third quadrant at an angle of beta minus alpha. And the first coefficient will give you the Vs into Vr by B will give you the radius of the circle. Using that, you have to form the circle. After forming the circles, next step is, after forming the circle, what you have to do is find the operating point in the arc, so that corresponding how much the real power and reactive power we have to deliver. So for finding that, what I have to do is, you see that the corresponding from here, if you measure that on the x-axis value, that is your real power delivered for that much of horsepower, and reactive power, how much you have to supply. These two things we can able to find it. Other than this, there are something called critical angle. That angle also from here, from the center, at an angle of alpha, you draw one line. The distance between the reference line to these two lines, that's NH line, will give you the corresponding angle called delta, and delta is called as critical angle. Yeah. Here max, you can able to use these formulas also. Beta minus delta is equal to 0. From there we can able to find it. So in that way we can able to find, these are some of the diagrams to find how much the reactive power supplied, how much the real power supplied, etc. And case 2, here also you can see that